a wooden cube first floats inside the water. 200 gram mass is placed on it. When the mass is removed, the cube is 2 centimeter above the water. The side of the cube. The previous problems, just that. Anybody gets the answer? You should tell me. Well, what is the volume of the water displaced here? The volume of the water displaced here is, everything is in CGS system, so 2 centimeters by L square, because they have told it is cube. Correct? Hello? So this gives the volume. Volume into density of water in CGS system is 1. Okay, and therefore that must be equal to 200. Hello?
Yes.
That's it. See, this volume into density, if I write, that must be equal to the mass, but density is 1 in CGS system. Therefore, L square will be equal to 100 and L will be equal to 10 centimeters. The other side of the cube, there is 10 centimeters. Okay?
Yes, sir.
Easy to conceive the problem, should not be difficult. See, it's all based on, this Archimedes principle. The watchword is, well, the weight of the volume of the liquid displaced is equal to the buoyant force, and this buoyant force is responsible for the decrease in the weight, or you get what is called as the apparent weight of the body, right? Or the loss of the weight of the body is equal to the weight of the liquid displaced. Okay, take some time and handle this problem. So draw the diagram. So take this beaker, piece of ice, so then you are going to take the water in the beaker. Okay. Now you have got a stone frozen in it on water. Piece of ice. Very nice. So you have got a piece of ice, right? This is a piece of ice, and then inside this there is a solid material. I suppose you understood, students. So this is ice, and this is the solid material inside this, and this ice is. I suppose you understood the problem. Hello?
Yes, sir.
Now, what happens? The ice is going to melt. The ice is going to melt, and then you will get the second picture here. What is the second picture that you are going to get? In the second picture, you are going to get it. So the water there. Yes, please.
Sir, we had done that when ice will melt, it will not increase the level of the water, sir. Now, when
Wait. Now I'm just solving it. You please solve it and be ready with the answer. I just complete this. Okay, I just complete this. So ultimately, the ice melts, and this is the situation here. So if I am to understand this problem, I will now separate these two things out. So what I have basically done is, I have taken the ice part and the solid part separated to begin with. But the volume of the ice is same. I have whatever ice volume is there, same volume I have taken here. Okay, so this was the construct, and now this ice is going to melt. So this ice is going to melt. Okay, and it is at 0 degrees, ice has melted. Okay, so what is the consequence? So going by this, you have got here the volume of ice, and this is the volume of the solid water. So now, see, imagine a practical situation. If I say there is ice and show it like this, is it correct? Will the ice be like this? Definitely not. No, ice is lighter than water. No, hello. Ice is, if you keep ice, it is going to float. No, hello. Isn't it? So therefore, our ice is actually going to float like this. It is not going to be inside. I mean, if I separate it out, that and this is going to be this situation. Correct now? Hello? So what I am trying to tell you is the density of ice is less than density of water.
Yes.
Okay, the density of ice. That means the mass is same. The mass of ice and the mass of water that it is going to get is same. Mass will not be changed. So therefore, now the volume of ice should be greater than volume of the water. Correct? Going by these relations. Hello. Therefore, now in this situation, what has happened? This solid body was inside the ice, and ice had gone inside the water. See, what you have studied in theory is, if the ice is floating on the water, hello, okay, and if it melts, then the level of water will not change. That is what is you have studied in the theory, and of course, correct, no? But if it was floating, but now that you have pushed it inside the water, now the situation is slightly different. So that means now this body had occupied the volume corresponding to this, and now after it melts, okay, the volume of this body will reduce because it will get converted to water,
Yes, sir. Yes.
right? And therefore the level here should decrease. The level here should decrease. Correct? If the ice melts, the level here should decrease. I am just going with the logic. Do you agree? Hello. The level should decrease by so much. Hello, clear? You are not participating,
Yes, sir.
students. You are also thinking. At least tell you are thinking. Right. So only Aniket is confident in telling yes, it will decrease. What about others?
Sir, but in this case, we cannot consider them as separate, sir.
No, I am just creating a hypothetical diagram. I am creating a hypothetical diagram. Nothing wrong. Nothing wrong. I have taken the same volume of ice and this. I have taken the same volume. I have not reduced the volume. I mean, of course, I have not drawn the hollow cube inside. Okay, if you take this place as hollow thing inside, I have removed this, then this is the same volume. I have not disturbed the volume of the ice. And
Yes, sir. Yes.
I go by this logic and I should get the answer decrease. Right?
Sir, but
Huh.
when ice is floating still, it will displace some water.
No, that, see.
The level would have increased.
No. Ice is floating, and if it had dissolved, the level of water would not have increased. It would have remained the same. Correct now? You have proved it. But now what we have done is, we have pushed it inside the water. Okay, so the situation is different. So now I will go by this logic. The density of ice is less than density of water, but the mass is same. Therefore, the volume of ice is greater than volume of water. You go by that logic?
Okay.
So what has happened here is now this much volume of ice has got converted into water, and then this is the size of the water, and therefore this excess volume will come down, and therefore the level of the water will come down. This is purely logic. The science only here is that ice density is less than this. That's the only science. But for that, everything is logic. Agreed?
Yes, sir.
Yes, sir.
Okay, so I think if it is wrong, then all of us are wrong. 53rd problem. B. Yes, B is the option. It just goes by logic. Okay, shall I proceed?
Sir.
Why are you taking so much time, students? Are you doing some calculation there? Hello, please speak to me. Are you doing some calculation?
No, sir.
Then what are you doing? Aniket, what are you doing?
Right. The diagram I introduced.
See, now when you read the problem, now all of you pay attention here. See, you are not developing the science in you, I am telling you. See, unfortunately, I will tell you, you have been made to solve numericals by applying formulas. Your head is, hello, everybody, don't solve the problem. Now pay attention here. See, unfortunately, you have been trained like, for this problem, this formula, this one. See, don't do like that. You see, what is the science that I have to apply, right? Your objective must be that, because you are writing a science examination, especially physics here. So here you see a rectangular block, so and so, the block is floating in water with 5 centimeter side vertical. If it floats with 10 centimeter. See, did the body is still floating? No? Hello? And in both the conditions, the mass of the body is same and it is floating, isn't it? So it is floating, the mass of the body is same. Then the volume of the water displaced should be same in both the cases.
Yes, sir.
That should be equal to the weight of the body because it is floating, isn't it?
Yes, sir.
So whether it is floating with 10 centimeter side up or 5 centimeter, how should that matter? Will it matter?
No, sir.
Then why you didn't think like this? See, that's what I'm trying to tell. You are not seeing the science. Students, please, ನನ್ನ ಮಾತು ಸ್ವಲ್ಪ ಕೇಳಿ, ನೀವು ಒಳ್ಳೇದಾಗತ್ತೆ. Okay, see, ಈ ಥರನೇ ಯೋಚನೆ ಮಾಡಬೇಕು. See, if you become engineers by solving 1000 problems and somehow you crack the exam, you will not become good engineers. And today there is enough proof to prove that. See, if you want to become an engineer, you have to look at the problem and look at the science behind this first. See, you have to use formulas and calculation to get the numbers. Okay, when it comes to numbers, yes, you have to do that. But mainly you see what is the science behind this. So what is the science in this? Law of flotation. Body will float. If it floats, it is going to displace, the weight of the liquid displaced is equal to the buoyant force, and that must be equal to the weight of the body. Now there are two conditions, one with 5 centimeter, one with 10 centimeter flotation. Body is same, mass is same. In both the conditions it is floating. So the buoyant forces must be same. Therefore the volume of the water displaced must be same. And that should tell you, fine. Okay, so what will be the change in the level of water? No change. Clear?
Yes, sir.
Don't you think this is science? Please put your hand on your chest and ask, is this not science? And what are you doing? You are drawing diagrams, you are drawing because you want to calculate. So first see what is the science, and then yes, to apply that science, if you need some more clarity like where are the force vectors, what is this area, how should I take, then you go with the drawing. And then you go with the formula. Okay, you be confident. Your focus must be on science. Right. So no change in the option. See the science and please answer. What is the science here? Come on, just now I gave a good lecture on that. What is the science that you see here?
So once it is suspended in water, sir, buoyant force will be acting on it, sir. That buoyant force, how much it is acting, we can find out by how much water it has displaced.
How much it has displaced?
But how much is the volume submerged?
How much is they are told it is suspended such that half the block is below the surface.
Yes, sir.
So half the block means how much will be the volume?
Half the block means half the volume.
That is 500 cc.
Yes, sir. That much volume
And
of
they are
water is
told,
also displaced.
and they are told it is suspended in water. So 500 cc corresponds to how much? 500 grams.
Yes, sir.
500 grams, they have given the answer in Newton. So 500 grams means 0.5 kg. And
Yes.
0.5 kg is the mass of the liquid displaced. And 0.5 kg, then what is the weight of the liquid displaced? 0.5 kg into 10, that is 5 kg, 5 newtons.
Yes.
So 5 Newton is the buoyant force. So
Yes.
in air it is 12 Newton. And now 5 Newton is the buoyant force. Therefore,
Yes.
the reading on the spring balance should be 7 Newtons.
Yes.
Yes.
See, I want to see if you see. I have taken 2-3 problems, similar type. I just want to see my students appreciate the science behind it, not the formulas. Okay, not the formulas. Please, students, see when you write the final examination, if you have gone with all the formulas in your head and all, then you will be in for a lot of tension and stress. Okay, and with that type of working, you cannot succeed in life. That is most important, not just getting into some college now. It's about your life after your graduation. Okay, so therefore, by oral calculation, you can get it as 7 newtons. Okay, fine. So you use logic and also science here. Wonderful problem. You can draw diagrams, you can do imagination, you can draw the diagram, understand this problem. Hello?
Yes, sir.
Now look at this. See, I am just breaking this problem into logic. I think the first one you understood situation number 1. There is the empty boat. Hello?
Yes.
No. First is sorry. The boat with stone. Boat with stones. Okay.
Yes.
Hello. This is the situation. Now I have removed all the stones. Okay. Then what happens? The boat will come up, and the level of the water will come from 1 to 2. Agreed? Hello.
1 minute, sir.
And I have removed the stones.
Yes.
The level will come from the level of the water. What happens? It will come down because the boat goes up. Hello?
Yes, but what about
Wait.
the stone?
Hey, ನೀನು ಏನು ಕುಡಿಯೋ ನಾನು ಎರಡನೇದು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮೂರನೇದು ಖಾರಿದೆ ಈಗ ಎರಡನೇ ಸಿಚುವೇಶನ್ ತಿಳಿತಾ
Yes.
ಈಗ ಮೂರನೇ ಸಿಚುವೇಶನ್ ಬರೋದು ಈಗ ಮೂರನೇ ಸಿಚುವೇಶನ್ ಒಳಗೆ ಏನಂದ್ರೆ ಥರ್ಡ್ ಸಿಚುವೇಶನ್ ಇಸ್ I have whatever stones I had removed, I am putting it back in the water.
Yes, sir.
Now the water level will rise to situation number 3. Got it? Hello?
Yes, sir.
The stones I have removed, I have put it in water. Then the water level will rise.
Yes, sir.
Got this 3 logic? Hello?
Yes, sir. Yes.
Now the important thing is whether level 3 will be here, okay, or whether level 3 will pass level 1.
Level 3 will be less than 1.
Why?
Sir, because when the boat was there below the level of water, so then it was partially submerged. Then wood was also there, stones were also there.
Yes.
And here the boat has already risen up, but only the mass of the weight of the stones is getting added. So it will obviously be less than wood plus stone. So it will be less.
No. Wood. See, the wood is there. You were telling that okay, the wood is up and the stone is down.
Yes.
The wood is there, stones are down, so it will rise up. My question is, it will rise above the level 2, but will it go and touch level 1?
No, sir, it can't go and touch.
Why it cannot touch level 1?
Sir, because when in situation 1, sir, there
more.
was contributing.
Okay, got it. So more wood was inside. Here less wood is inside.
Yes.
Okay, that is your logic. Okay, fine. So do you agree? Hello, students. Hello.
Yes.
No, don't simply say yes. If you have understood, you say yes. And I want the confident yes here, not the defeated yes. So your friend has captured it correctly. So he says now in this situation, if the stones were there, the boat also would have been below, right? The boat also would have been below. The boat itself would have been below. So this much volume, if it is added, then it would have come to level 1. But that much volume will not get added. So it will settle down at level 3. And level 3 means what? What will happen to the level if the stones are unloaded? The level will fall. Is the answer?
Yes, sir.
B is the option.
Yes, sir.
Agreed?
Yes, sir.
Which is this problem? 56th problem. 56B. Wait, we got the answer B. Okay, fine. Okay, I think this is a good work, no? Like assuming things like this and getting the conclusion like this. See, I have not used any formulas at all here, okay? So it's just by logic, things have been worked out here. So there is some other thing like concept is, the equivalent, the volume of the water that is displaced on account of the stones inside the boat and the volume of the water displaced only by the stones. So you will find that the volume of the water displaced by the wood, by the boat, because there is stones inside it, will be more than when the stones are taken out. Okay, that is also good. Okay, friends. So